To many enthusiasts, a car is more than just a mode of transportation. It's a lean, mean, well-oiled machine, one that requires a lot of maintenance with the very best of products. Like these liquids, each with their own unique property, serving their own unique function. Knowing how these properties affect your car can make all the difference between the wrong choice and the right. So, what's the chemistry behind choosing this specific liquid? Let's find out. Welcome to a rather fluid edition of our chemistry show. That's right. Today we are talking about liquids and their properties. And considering that over 60% of our planet and bodies comprise of liquids, this is an episode you won't want to miss. On today's show, we will take an in-depth look at the liquid state of matter. We will study its physical properties such as vapor pressure, surface tension and viscosity. We will then discuss important questions and exam tips in Exam Decoded. We all know that physical matter exists either as solids, liquids or gases. But what makes them behave so differently from each other? For this, we'll have to go into the microscopic universe of molecular structures. In solids, the intermolecular forces of attraction are very strong, so molecules are very tightly packed together. In liquids, the intermolecular forces of attraction are relatively weaker as compared to solids, so molecules have more free space between each other. Gaseous molecules have the least amount of intermolecular forces of attraction and so the most amount of free space between the molecules. As the intermolecular forces in the three states vary, so does their behavior. As we just saw, liquids have stronger intermolecular forces of attraction between them than in gases. So their molecules don't separate from each other as easily. Intermolecular forces are strong enough to hold the molecules, restricting their movement and hence resulting in a definite volume. However, they do not have a definite shape as these intermolecular forces are weaker than those in solids. So, the molecules in liquids are more flexible in movement. This means that liquids do not have a definite shape. Like what I have here, the same volume of water, when poured into three different containers, take up their shape of each one. I am sure all of you know that evaporation is a characteristic property of liquids. But what if your examiners asked you why certain liquids evaporate faster than others? What would you write? Don't worry, I will show you through a simple example. I have with me some acetone and some water. Look what happens when I pour little bit of each of these into the petri dish. Acetone, water. You can already see that the acetone has evaporated while the water is still liquid. Now, intermolecular forces in acetone are weaker than those in water. If the bonds are stronger between molecules, they won't be able to escape as easily and vaporization will be less. Now, can you guess why the car mechanic chose the lubricant over the coolant? Engine lubricant is an oil which has strong intermolecular forces. Even at high temperatures, it does not vaporize and so effectively lubricates the engine parts. But coolant has weaker intermolecular forces and vaporizes easily. It may not lubricate the engine, but it takes the heat of the system, gets vaporized, and then condenses elsewhere in the vehicle. So mixing these two liquids would have been very bad for the car. Now let's look at acetone's behavior in a closed container. You will note that a number of molecules which get vaporized hit the walls of the container as well as each other. Some of them rebound and have enough energy to get back to the liquid state. That means there are two processes occurring simultaneously: vaporization and condensation. Eventually, a state is reached when these two processes occur at the same rate. This is known as equilibrium. If you measure the pressure of the vapor in the container using a barometer, it will denote the vapor pressure. This pressure is called equilibrium vapor pressure or saturation vapor pressure. Now, vapor pressure is a very important property which goes on to influence another important phenomenon in liquids: boiling point. What happens when we heat about 100 milliliter of water? As the minutes pass, the molecules of water begin to get agitated. Soon, bubbles begin to form and steam rises. Now, if you measure the temperature in the beaker, you will find it is 100 degrees centigrade. If you check the level of water, you will find it has reduced. This is because the water has boiled, which in turn happened because the vapor pressure of the liquid became equal to the external pressure. The temperature at which this happened, that is 100 degrees centigrade, is called its boiling point. What do we deduce from the above example? That boiling point is intrinsically connected with pressure. Boiling points for all liquids calculated at 1 atmosphere pressure is known as normal boiling points. Sometimes pressure is calculated in bars, with 1 bar equal to 0.9869 atmosphere. In this case, boiling point at 1 bar pressure is known as standard boiling point. When external pressure is high, boiling points increase. This is because a higher temperature is needed to create enough vapor pressure to reach equilibrium with the external pressure. Similarly, low pressure conditions lead to lower boiling points. This is because less vapor pressure is required to equal the external pressure. So remember, boiling points increase with increase in external pressure and they decrease with decrease in external pressure. Not unlike you students. When the exam pressure is high, your stress levels are high. When exam pressure is low, your stress levels come down. Luckily, I am here to alleviate some of that stress. Here is a typical exam question from the topic we just discussed. Which temperature will water boil at higher altitudes? Is it 120 degrees Celsius or 90 degrees Celsius? At higher altitudes, water will boil at 90 degrees Celsius because atmospheric pressure is low. At lower pressures, less heat is required to change the liquid to its vapor phase. Thus, water boils at lower temperature than its normal boiling temperature, which is 100 degrees Celsius. Let's see how effective I have been and if you are able to apply what I have taught. Here is a question. Once a liquid to vapor equilibrium is reached, what happens if some vapor is allowed to escape? Will the condensation rate increase or decrease? Well, the pressure is on. I'll catch you on the other side of a short break with answers. Welcome back. Before the break, I had asked you whether the condensation rate of liquids would decrease or increase if some vapor was released after liquid-vapor equilibrium had been reached. The answer is the rate of condensation would decrease because the number of molecules returning to liquid phase will decrease. It is time now to move on to another fascinating property of water that even enables certain life forms to walk on water. I am talking about surface tension. Here is a spot of magic for you. I am going to sprinkle some sulfur into this glass of water. What do you think? Will it swim or sink? Well, as you can see, the powder remains on the surface. And this is the stretched membrane which supports the weight of tiny insects called water striders that walk on it. Time to take a question from our viewer now.
We have studied that liquids take the shape of the container they are put in. But when we release a liquid from a pipette, the shape of the drop is spherical. Why does it happen?
Interesting observation. Here is the reason. As I just explained, molecules in a liquid are acted upon by strong forces of attraction amongst each other, and a bulk of the molecules are subjected to forces from all sides. But molecules on the surface only experience inward forces from below, and the surface of a liquid becomes like a stretched membrane as the molecules are pulled inwards. As the liquid tends to minimize its surface area, it assumes the most efficient shape, which is a sphere. So, we can define surface tension as the force acting at per unit length. It is denoted by gamma, and its SI unit is Newton per meter. Now let's correlate temperature and surface tension. When the temperature of liquids increases, the intermolecular forces of attraction decrease, thereby decreasing surface tension. Conversely, any decrease in temperature leads to increase in these intermolecular forces. So, the surface tension increases. I could watch this swirling liquid all day, and not just because of its hypnotic effect on my mind. If you look closely, you will find something very interesting. The layer of water that's touching the glass comes to rest much before the innermost layers. Why is that? Well, this is due to the resistance of the liquid to flow, otherwise known as viscosity. So how is viscosity manifested at a molecular level in liquids? Well, viscosity is generated because of friction between different layers of molecules in a liquid and between the liquid and its neighboring surface. As one layer of molecules flows over the other, the difference in velocities creates resistance between them. In this example, as we move away from the more stationary layer, that is, the walls of the beaker, resistance begins to lower. So, we found that in the center of the beaker, the flow of water was the most rapid. Numerically speaking, viscosity is given by F is equal to eta times A dV over dx, where eta is the coefficient of viscosity. The coefficient of viscosity is defined as force applied for every unit area that maintains unit velocity difference between the two layers of a liquid, which are at a unit distance from each other. Simply put, the higher the coefficient of viscosity, the more viscous a liquid is. The units of the coefficient of viscosity are Newton second per square meter or Pascal second. In the CGS system, its unit is poise. Now, if viscosity is the resistance to the flow of liquids, what would be its opposite? The inverse of viscosity is called fluidity. This means that when viscosity goes up, fluidity goes down and vice versa. What factors can affect this relationship? A major one is temperature. Liquids flow because their molecules are constantly on the move, filling in empty spaces called vacancies. Now, when the liquid's temperature is increased, it raises the kinetic energy of the molecules, as a result of which they begin to occupy vacancies at a faster rate. So, the flow of the liquid becomes faster, reducing its viscosity. And since the flow of the liquid becomes faster, its viscosity is reduced. Even though I am a teacher, I believe that those who know how to think need no teachers. It's time now to flow into our next short break. But let the force of attraction bring you right back, because next we are going to be talking about what you can expect in the exams. Welcome back. It's time to talk about the possible exam questions you can get from this topic. But first, let's do a quick revision of what we have learned so far. Liquids have definite volume but indefinite shape. The pressure of vapor in equilibrium with its liquid phase is known as equilibrium or saturation vapor pressure. Surface tension is defined as the force acting at right angles per unit length. And viscosity is the measure of resistance to flow. Now that we have brushed up the basics, let's move on to our next segment. Time for Exam Decoded, where we will make all those dreaded exam questions simpler. So strap on your seatbelts, because it's time for the rapid fire round. In this round, I'll be asking you 5 questions. You will have to be quick, because you will only have 5 seconds to answer each one. Every correct answer fetches you 1 point. Here is your first question, and it's an easy one. According to the CGS system, the unit of viscosity is poise. True or false? The correct answer is true. Next question. Is this true or false? The vapor pressure of a pure substance depends on the relative amounts of liquid. The correct answer is false. The amount of liquid doesn't matter, because vapor pressure is only dependent on intermolecular forces. Here is your third question. It is a commonly asked exam question. Why is a water drop spherical? Because of vapor pressure, surface tension, viscosity, laminar flow of liquids. The answer is B, surface tension. Second last question for 1 mark. Viscosity is the resistance to which of these? A, heat, B, stirring, C, fluids, D, flow. I hope you have all got D. This is because viscosity is the resistance to flow. Last question. Which of the following will affect the fluid flow? A, surface tension, B, viscosity, C, vapor pressure, D, all of the above. That would be B, because greater the viscosity, slower is the flow of liquid. Let's look at the scores now. If you have got a perfect score, you are a high flyer, which means that your preparation is going very well. So keep it up. 4 or 3 marks makes you an achiever. which is great, although a little more work won't hurt. Less than 3 marks makes you a learner, and you may have to step it up a bit. But whatever your score, do log on to www.topperlearning.com for more practice tests, because a bit of practice goes a long way. The chapter on states of matter carries 4 marks and it is rated important. The most commonly asked questions pertain to the knowledge ability type. These questions test how much factual information you have imbibed from the lesson. Here is an example. Will normal boiling point and standard boiling point for water be same? This is an average difficulty question for 2 marks. The answer is normal boiling point is defined at 1 atmosphere pressure and standard boiling point is defined at 1 bar pressure. This is for 1 mark. Now since 1 bar is slightly less than 1 atmosphere pressure, standard boiling point is less than normal boiling point. This will fetch you another 1 mark. What about other question types? And what topics are more likely to be asked? Let's ask today's expert.
As discussed about the liquid state in the states of matter, we'd like to discuss about surface tension and viscosity. Surface tension we know is a surface phenomena. It decreases with the increase in temperature. It also decreases with the addition of some solid or liquid substances in the solution. Surface tension can be measured with an instrument called slagmometer. Surface tension of polar solvent is high. Surface tension of non-polar solvent is low. Surface tension of soaps and detergent is generally low, and that is why they are used for cleaning clothes. Now we'll discuss about viscosity. Viscosity decreases with increase in temperature, but it increases with increase in pressure. The reciprocal of viscosity is also called as fluidity.
Focus on these areas and you will do very well in this topic of properties of liquids. It is time for me to leave you now. Until we meet again, observe, question and seek, because chemistry is all around you.